Imagine running a business. You have annual sales of maybe $100,000, $150,000 a year, and some advertising service, social media, could be Facebook, could be Google, could be anybody, comes to you and they say, have we got a deal for you? $500 a month and we'll increase your sales, you'll make more money, you don't really have to do anything. Sounds wonderful, right? You pay the $500 a month, maybe your sales go up, maybe you're seeing more sales, but it's not a dramatic effect. It's not doubling, tripling your sales where it's obvious, but it might be paying for itself. It might be significantly increasing your profits, but you're not quite sure. How do you figure out, is it worth going with these people and continuing to pay that $500 a month? You could use that to pay for a lot of things or just put it away in the bank for the future. Proxy measures give you more detail. So how many times people clicked on a link, how many times they viewed a video you put out. The problem is they can be highly misleading, even if they're very positive. You might be seeing a lot of clicks on your website, a lot of indications of interest, but actually your sales really haven't gone up. In fact, you can have a lot of views of an ad, and people are turned off by the ad. They actually are buying less. It's just that your ad has something that draws people to it and makes a bad impression. So how do you tell? You have to look at your sales data. You have to look at what's in QuickBooks or whatever financial accounting program you have. Is it going up? Well, this is an example of comma-separated values files exported from QuickBooks. Actually, it's a simulation of data exported from QuickBooks. It's modeled on a business that I've done some work with. The point is, this type of data, whether it's in a spreadsheet format or it's in a comma-separated values format or it's in QuickBooks, it's actually hard to figure out what's going on. You have transaction records, you have some number of dollars you bought per day. Is it really going up? Again, if it's dramatic, you know, but maybe it's not dramatic. So then this data, there actually is a positive effect from the advertising. So we compare the periods without the advertising and with the advertising, and we look at the fraction of days that we have 0 unit sales, 1 unit sale, 2 unit sales, etc. So if you look at these, you can see very, very easily that there's a dramatic decrease in the fraction of days that have 0 sales. There's a slight decrease, or excuse me, there's actually also a substantial decrease with 1 sale per day. We see about the same number for 2 sales per day, a noticeable increase of days with 3 sales, a noticeable, actually quite a large increase in days with 4 sales per day, and about the same for more. So it looks like the advertising is working. Can we make that more solid, more quantitative, more predictive? That's where analytics, where statistical methods, where mathematical modeling comes in, which is what I'm going to show the results of next. We can take those fractions that we empirically measured from the period without advertising and the period with advertising. We can take those empirical fractions, we can simulate the operation of the business for a year, and we can do those simulations over and over again, 1,000 times, as if you ran your business 1,000 times. Because sales is random, like flipping a coin, every simulation will have a different result. Each simulation will have different profit, a different amount of sales. On average, you can see what the likely outcome is of using the advertising. So in this plot, we have 2 types of simulation outputs. We have the green plus signs, which show the results with the advertising program, with the higher fractions of 3 sales per day, higher fractions of 4 sales per day. The blue circles indicate simulations without the advertising. There's a natural variation because of the randomness. The sale is like flipping a coin. It has a random output. You might get the sale, you might not. And so there's going to be a natural variation, a certain risk of different outcomes simply because of random chance. It has nothing to do with the advertising. What we want to know is, on average, over those simulations, do we make more money? We can see quite easily that we do. The black vertical line shows us an average expected profit of almost $6,000. It's actually an increase in the profit if we're running the advertising. That takes into account the cost of the advertising, the $500 a month in this case. So on average, there's no question here that the advertising is likely to benefit our business and we should continue to do it. That's great, but that's not the whole story, and that's not everything you get out of doing a mathematical model and simulation of your future sales with and without the advertising. You also want to consider risk. There's a risk that you'll just have bad luck. Even though the advertising works better, you're always paying over a year $500 a month, $6,000 for the advertising. So what if you have bad luck and for whatever reason, even though the advertising in general will work, it didn't work that year? Well, your profits might decline by that $6,000 because you're guaranteed to spend that money. So this plot allows us to see the increased risk that we're taking when we do the advertising. So this blue circles represents without the advertising. We aren't taking the extra risk. With the advertising, we have the green plus signs. We can see there's a small chance, maybe about 1% here, we might actually have less profits than without the advertising. On the other hand, on average, and most of the time, we will in fact make more profits. Whether you want to continue the advertising is thus a combination of the average, in general, how good is it going to be, but also your tolerance for risk. Do you have enough money in the bank? Are you making so much profits that even if your profits went down, you still have a viable business? You have to look at both of these, the potential reward and the additional risk you're typically taking when you're paying for advertising or marketing or some service like this. So these simulations allow us to take the empirical sales data that you have from QuickBooks or other programs and do a simulation which allows us to see potential reward, the possible increased profit, the probable increased profit actually, and also the potential risk that you're taking by spending more money on the advertising. This was done with our free open source ad evaluator program, and this will take in data in comma separated values format from QuickBooks or any financial accounting program. It looks at a sales report and produces these reports and additional information you can find out on our website. You can get it at a downloads page. You can go to mathematical-software.com and then click on the downloads tab, or you can use this URL here, wordpress.jmcgowan.com/wp/downloads. You can also use this QR code, scan the QR code, and bring up the website. We are also working on a professional Ad Evaluator Pro, for which we will charge money, which handles more complex cases, multidimensional cases, where in addition to one change, like we pay for advertising, you have numerous other changes going on. Your product changes in price, there's other advertising programs, the economy changes, all these complex factors are taken into account. That is more difficult, and we will charge money for that. But if you just have a single change in your situation, you just pay for one advertising program, like the business that I modeled this on did, you can actually see with the free program whether the advertising is working or not, and how confident you can be that it's working, and what the risks are that you're taking. That concludes this video about Ad Evaluator, the free open source version.